I'm David Stein. I'm a senior staff software engineer at LinkedIn working on MLOps and machine learning infrastructure. And coffee, I like my coffee black, and I love Phil's coffee, and I have been mail ordering it and making it home since the pandemic.
Mr. Skylar, welcome back. This is awesome to have you here. Today we're talking with David Stein, a fellow buddy of yours from the LinkedIn days, and there's a lot we chatted about. I've got so many cool takeaways, but I want to hear yours first.
One of the biggest takeaways for me was just a lot of the talk around, first of all, open sourcing Feathr and sort of the journey to get there.
Mm.
And then also kind of like what's next. And it was really interesting hearing David's perspective because when David started building Feathr, feature stores did not exist. That was not like a term that was floating around at all.
Yeah, what was
And
it,
so
2016?
this was probably 2015, I think, when they
Yeah,
started.
wow.
Maybe 2016. But it was,
Mm.
this was definitely like one of the OG feature stores for sure. And so David has kind of been in this space and just steeping in this problem for a very long time. And I loved hearing about sort of like how they got to this point of like having an open source release and using LinkedIn really as an incubator to like build a really great product.
That's such a good point. How he at the end mentioned LinkedIn, he could build a better product at LinkedIn than spinning out his own company because he has so much access to people like you back in the day that he could just go and sit next to and read their code or ask questions and have a relationship with and bump into in the cafeteria at lunch. Like that is such insight that I hadn't even thought of because automatically you go to like, oh yeah, why wouldn't you start this on your own? You've been doing feature stores since 2016, 2015. Like go and do this. And so he gave a nice little plug as to why building it at LinkedIn was arguably a better option than going and building it out in the world. And I personally loved when he talked about how he does not feel like real time is being so quickly adopted because the tools are not in place. And so I think that's huge. I know there's a ton of companies that are trying to go at this real time problem. You mentioned chips. I know Tecton's starting to do a lot of their stuff with real time. There's a few others that I see like it's almost every other week. I feel like somebody comes out and says like we're the XYZ platform for your real time data. And there's a problem there. There's definitely like people are looking for a solution. And the way that he broke down why it is so important because of the ability, if someone has confidence that the tools they're going to use are going to work and they're going to be able to use them quickly, then they get that many more cycles on them. They get that many more iteration time or that much more iteration time to go through it. It just makes them more likely to try that use case XYZ with um, with real time features and real time capabilities. I did also like how you pushed back a little and said, well, not everything is for real time, right? Not especially you've been working on it. And I know this is a strong belief that you have. Like real time might be overkill a lot of the time. It's not necessarily the most important thing to have these real time features coming through because the features aren't going to change over the course of an hour that much. So that was huge. And at the risk of just babbling on a little bit more, I also wanted to talk about when he said the idea of making things more simple so that machine learning engineers can understand what they're working on and then decoupling features from code that kind of blew my mind and having this features as something that engineers and whether it's data engineers or data scientists or machine learning engineers they can reason with, they can look at, they can change, and it's irrespective of the code that built the model. So
Mhm.
that was a huge one. It's probably one that is not such a big surprise to people, but I got a thick skull and it takes a while for things to enter into my mind. And this finally was, he put it in an eloquent way so that I understood. So David Stein, he is a machine learning engineer on the platform, on the Feathr platform at LinkedIn. And we talked to him about so much good stuff today. And that's it, man. I don't have anything else. Do you have anything else you want to mention?
Only that it was a pleasure getting to chat with David again. David is a careful thinker, and I always appreciate, regardless of how loudly I would rant at LinkedIn, he always found a way to respond calmly. So really, really appreciated the opportunity to chat with him again.
Yeah, it seems like he would have been awesome to work with. I'm sure you enjoyed that. And I know that you told me just before we hit record, like you would happily work with him again. And so we do got to give a shout out to you're having a happy hour in LA for the MLOps community.
Yeah, tomorrow night.
There it is. Well, it's probably
By
like
the
a
time
week
this
ago by the
airs,
time this exactly. So, but you're going to be doing more. So if anybody's in LA and they want to hang out with Skylar or Hod or any of the LA crew, then like there's a whole meetup page. We've got meetups happening all over the globe in real life because we're sick of being behind screens and we've done enough virtual events in the last 2 years. Let's get out, meet each other, and hopefully we're going to be giving away fun things like at certain meetups. I was just talking to the Berlin crew, and we're going to be giving away Raspberry Pis for different trivia contests that we're doing. So we're going to try and make the in real life meetups fun and a good time. You're just doing the happy hour. Maybe later on it's going to develop into a full blown meetup. Let's see. All right. So without further ado, we're getting into it with David. All right. Where do we even begin with this one? I think we should start with the fact that Skylar and David both knew each other back in the day when Skylar was working at LinkedIn, and this is a reunion of sorts.
Yeah, I'm definitely super happy to see David again. Really enjoyed working with him in the past, and so glad to see he's doing well.
Yeah, I was just gonna say likewise, Skylar. It's really great to to be here again with you, for sure.
So since the time of working together, you, David, have been very busy because you created this feature store that LinkedIn uses, and then you not only created it and were using it at LinkedIn. Later, Skylar can tell us if you guys were using that back in his day, but you open sourced it. So I want to get into the feature store. I want to get into just the ML infrastructure at LinkedIn, where you think MLOps is going, and then the whole experience of open sourcing something, because I know that can be a bit of a beast and how it's been so far. I just got to comment one thing before I ask you the first question. I love this background you've got. It reminds me of like when Neo and Morpheus jump into the Matrix right before they jump in and they're like, everything's white. And then all of the different shelving comes in around them. I'm expecting shelving to come in around you at any moment when you have to talk about the different tools that you used at LinkedIn. So, but anyway, man, why don't we start out with this? Like, can you give us just a bit of background on Feathr and what exactly this feature store is? We probably know what a feature store is. I'm guessing a lot of the people that are listening have heard it many, many times before, but what is Feathr's unique feature store-ness?
Sure. So Feathr started out really like 6 years ago. It had a different name internally at LinkedIn for a lot of its history. So Skylar would know about it probably mostly by its name Frame that we've also talked about publicly. I think it's mentioned in the blog post about Feathr. But yeah, we at LinkedIn years ago, because we've been doing ML, using it in production for a lot of LinkedIn businesses for a long time, like more than 10 years. Recommendation systems for the news feed, for advertising, for notifications, relevance, for all different kinds of things. And there's lots of like, research papers and other blog posts that LinkedIn has put out about a lot of these applications. We've been doing a lot of these things for a long time. And a huge issue that we encountered is that preparing features and managing the features, so they're the inputs to machine learning workflows, is really, it's a big part of the challenge in kind of operationalizing and managing machine learning workflows. So we were even saying that it's in some of the large machine learning applications, it was even like the hardest or the most complicated, burdensome thing to actually manage these feature data preparation workflows that had been growing for years, and different generations of people on the team, like years of turnover and new engineers and researchers coming in and adding a new feature here, a new feature there, adding a join here, a join there. We started to see these giant, complicated workflows,
Yeah.
kind of for using like Azkaban, which is LinkedIn's kind of internal version of Airflow that's also open source. Basically, like all of these big data processing workflows that have gotten really complicated, that really were trying to do something that I thought was simple, should be seen as a simple thing, which is define a set of features, compute them from their source data, load them into the context for training, and then be ready to do the same thing for online and production. So I guess I could say that, to say that a little more simply, feature preparation is like the hardest thing. One of the hardest parts of actually doing applied ML at scale for a large project for team over time. And so we built Feathr as a solution to kind of simplify feature preparation, to make it so that you define a named set of features and then get those features by their names in the training context and in the inference context, instead of having to like manage a whole bunch of application specific workflows to do that. That's sort of the origin story. I'll let you steer me with more questions about what facets you want to go into.
Yeah, definitely. And one of the things that is really awesome that I just want to point out is you talking about how you started this project like 6 years ago, and I remember the very, very earliest days of Frame, and it's really cool to see the milestone and landmark of like actually seeing it become like a full-fledged open source project. And Mostly first want to just congratulate you because like obviously that's a lot of work and a lot of cycles that you had to go through, a lot of learnings. Um, and so One of the things that I was curious as you were talking about this is, you have like 6 years of lessons to learn. What do you think are like the lessons that you learned in building this? Because like one of the things when we were talking to Hian the other week, LinkedIn was in this interesting position where like feature stores didn't really exist, so to speak, when you started this. And so you're kind of like one of the people that sort of spearheaded, the creation of feature stores. And so like I'm sure there's tons of interesting lessons you learned along the way about what works in feature stores, what doesn't, how to get people to use them. So really just curious to get your take as what stands out as important learnings.
There's so many lessons, both in terms of how to help a team deliver some technology mission, especially when it's in a new space like this, where we're still collectively, I think, as an industry, figuring out what the right solution for a feature management platform and for feature stores should look like. Leading a team to deliver it, and refocusing the needs based on what we hear from users. There's many lessons in there. I think one of the things that I think was most important is the importance of, it almost sounds obvious, but having really clean concepts that are going to work well for users. Like something like this with a feature store, uh, we I view it as um, it is a device to actually help the users, who are the machine learning engineers, think more simply about the system, about the machine learning platform, the thing that they need to be deploying their models into and running them. And when we're trying to make it easier for people to think about what they need to do, you need to have really good, clean concepts. You need to have named things that resonate with people in the work they need to do. Getting those concepts really clear early on is really helpful because you have to course correct less later on. And when we make mistakes, like if we make things more complicated than they should have been, if we didn't polish down tightly enough some core concepts, those become, increasingly challenging things that need that, the cost of fixing those problems goes up later on. So I mean, there's many different kinds of lessons there, but the clean concepts, starting from the point of asking users and working together with users to figure out how do you want to specify things? How do you want to specify your feature dependency set of your model? How do you want to specify a feature definition? Can we use like a imagined configuration or imagined DSL as a sort of a thought device to shape how we want to think about the things that we want to build? The importance of those things early on in a design process, I think, contributed to the success and longevity, I think, of what we built for this project. I don't know, but there's many other angles to go here. Hopefully that covers that question. I don't know if there's
Yeah.
different angles in there you want to go.
Yeah. I think that's great. Yeah, and I think that's definitely a lesson that resonates with me. Seeing a lot of the churn that we had and trying to figure things out early on, I definitely recall like unclear semantics, like definitely made my brain hurt. But yeah, so one of the things I'm sure that a lot of listeners will be curious about, because I don't think everybody has a good understanding of the scale of LinkedIn. And so would love to talk about the scale that you're handling from a few different angles. One, how many teams are using Feathr? Two, how much data, like size, are we talking about? And I think people would love to kind of like hear those bits on scale.
Sure. So I wish I had my, cheat sheet of the LinkedIn published, like
Yeah.
known and publicly released numbers about these things. I know that the, just in terms of scale, LinkedIn obviously has many hundreds of millions of members, and then numbers for, I assume that there are some numbers that folks who are really interested in LinkedIn scale can look up, things that are probably described on blog posts in terms of the scale of the number of people who are coming to the website every day,
Hmm.
using different products, the number of different kinds of entities that need to, the number, I mean, just the scale of the number of people using the product. Um, and I think that most people who use the LinkedIn product, who, for example, use LinkedIn feed and know, you can scroll and scroll and scroll, and the diversity and variety of kinds of things that will show up there. You can think of the scale of some of these kinds of applications that we're dealing with. It's a
Hmm.
very, I would say, like a large, one of the, uh, I wouldn't consider to be like at the magnitude of scale of something like in terms of traffic load and things like that, or in terms of the data volume. It's going to be like one of the larger use cases, right? And without speaking to the specific numbers of these things, um, number of teams using Feathr. Um, this is, I guess, it slightly depends on how you count in terms of sub teams, big teams, but there's
Hmm.
like dozens of teams who are using
Hmm.
Feathr. Most of the internal users know it by those same internal kind of code names that Skylar that you knew, as particularly Frame, although there's a couple of other pieces inside that also are wrapped in the Feathr umbrella. Um, the the history kind of went like this project started in 2016 and then really got implementation in 2017 with a collaboration with engineers from various different machine learning, like applied ML teams who were building different parts of the stack. It was a very kind of close partnership kicking this things off kicking this thing off, and there was a lot of um, early kind of grassroots enthusiasm about this idea because it was this, widely, commonly understood issue that there's a big opportunity in simplifying the feature preparation aspect of building machine learning application and workflow. So we had many adopters in the first few years that helped us build this, and then we went through additional migration phases in the years after that, where I am pretty sure it is a good majority of the applied ML use cases at LinkedIn that are using this technology.
So I want to take a little bit of a step back because there's something that you said in that answer a few questions ago, where you were talking about how Feathr is this device for a machine learning engineer to think more simply about the system and interact more simply with the system. And I thought that was something that I hadn't heard before, because it's like you're taking basically this very, very complex thing and you're serving it up to the machine learning engineer in a way that they don't have to understand the whole complexity of everything that's happening, but you're making sure that they do understand the important parts and the parts that are pertinent for them. Am I understanding this correctly?
Yeah, I guess to add a little bit to that, the idea of having a feature for especially an entity feature, which is like the big important case for feature stores, where you have features about users or features about job postings or features about feed items or about advertisements that need to be managed and fetched and looked up. The idea that you have a named set of these things that can be captured in a registry, that can be reasoned about apart from the code that creates them or apart from the models that use them, was sort of an innovation, really. Before feature stores and before Feathr, you would have named variables for features in model code, but they were kind of coupled with the model code or coupled with the workflow that's doing the data processing. The idea that there should be a named entity, named almost like an artifact or a named abstract entity, like a thing that is a feature that is registered in a registry and has a name, and that you can rely on that name meaning the same thing in the different parts of the ecosystem, right? Like in the experimentation, offline, sandbox environment, and also in the online production serving environment, that you can use that same name and expect it to mean the same thing, and you just get to ask the infrastructure to provide that feature for you, and you can rely on it being the same, like in the training time and in inference time, and that the underlying machinery is going to make sure that that is the same. Being able to rely on that set of named features in a registry, where first you add the features and then you use the features, is sort of a simplifier, because before that, the engineers working on these applications would have to think to a much greater extent about the details of how this data preparation needs to work. They might have different names for feature columns in one context and other names for them in an inference online context, and they'd have to write code that would need to remember which feature corresponded to which. Having these things ordered in a common registry with common infrastructure that can provide it does kind of simplify the things you need to think about. You're like, okay, I have a set of features. I import them into my model context, kind of like you import dependencies into your code at the top of your Java or C++ file or something like that. Getting that cleanliness around named importable features does help you think about what you need to do in terms of building and deploying a machine learning model.
I love this idea of decoupling the features that you can reason with from the code too, and then bringing that standardization so that across the company you understand that you have this named thing that is going to be the same whether or not I am here or there. And it reminds me, this is a horrible like analogy, but I saw Skylar drinking some coffee, and it's like going to a Starbucks. I can go to Starbucks anywhere around the world, right? And I know that the coffee is going to be pretty much the same. It's any kind of fast food chain that you have that dependent, or you have the predictability in when you go in there, it's going to be the same. And so that's kind of what it feels like you were trying to do, is make that predictability across the organization, so that when somebody is messing around with features, they know that they're messing with this thing that is not that is the same across the org. And so I'm wondering too, when it comes to open sourcing this, because it feels like that helps with the standardization piece. And I actually was just recently listening to a podcast with the founder of HashiCorp, and he was talking about how open sourcing, in his mind, the key to open sourcing, especially for HashiCorp, was to drive standardization. Was that at all in your minds when you decided to open source it?
So I'm not familiar with the example that you just mentioned, so I can't compare to that specifically. But I know of other examples where of projects and systems where the open sourcing of a thing is specifically a play to standardize. Like I'm thinking about things like Onyx, for example. It's like, let's define a common language for how model graphs can be represented, for purposes that brings. I would say that the reason why we open sourced Feathr is maybe a little different from that. We at LinkedIn, we have a kind of a culture of open sourcing our infrastructure pieces that we build, that we're proud of, and that we think may be of interest and use to the outside world. There are many examples of other LinkedIn projects that have been open sourced and that have made an impact in the industry. People talk about Kafka, Pinot, Data Hub, and there's others. So we believed with Feathr that we had a interesting solution to a problem we saw and we're hearing about increasingly from folks at other companies. And so we, in the same kind of spirit of open sourcing generally useful things that we build at LinkedIn, we wanted to put this out there because we do think that our approach to the problem of organizing feature preparation is like a good one when compared against kind of like what is commonly available out there. So we did that's kind of the part of the thinking behind why would we do that. There's a lot of benefits, right, also to open sourcing, to undertaking that process of open sourcing internal tech. Like there's a whole effort around cleaning things up, getting it ready for the public eye, improving your documentation a little more, cleaning up some facets of things, doing a lot of that work that we also would do for internal projects, but it's sort of like a motivating occasion to do it. There's various benefits, right, that you get. But we did believe it was useful, and we also have a partnership with with a team of folks at Microsoft Azure who've also published a blog post about this collaboration, where they, kind of got a early inside look at what we were thinking about open sourcing with our feature store solution. They were interested in, working with us on this. So we've got some collaboration on this open source project from folks at Azure who've made really awesome contributions in terms of making Feathr easy to use and easy to try and deploy on Azure. So there's a lot of stuff about that in the blog post that they published, and on our GitHub page, folks can go there and see how it's been really made into like a cloud native solution that's easy to try on Azure. So all of the the interest from our partners at Azure and the interest from folks we've talked to in the industry, these are all kind of factors that led us to undertake this initiative of open sourcing Feathr that had been in use for LinkedIn for quite some time.
That's awesome. So, one of the things I was just remembering, a long time ago, I stumbled across this website, featurestore.org, and I had looked through it and noticed, hey, LinkedIn doesn't have anything here. And I had pinged David at the time. I was like, hey, man, what's up? Why isn't your work here? And I just went and checked, and Feathr's there now. And it's really interesting seeing just how many feature stores are represented there. And I'm sure you, being somebody who is steeped in that problem space, you're probably aware of how other people have built their feature stores. And I'm just curious, what are some of the things that you see as differences between Feathr and maybe some other feature stores? Especially differences that might be important, maybe things that are better, worse.
Sure. There are a lot of solutions out there. And something I think I mentioned earlier was about how the industry, we're all kind of together still deciding on like what a good feature store even really means as a, what is the requirement set? What are the functionalities needed? Um, it's still, like in development, even the names, the name feature store.
Mm-hmm.
Um, and what it even really means. Like, there's been some actually shift in terms of what that means. So if you look at the solutions there, I think that there you see a variety of approaches. You see some that are um, much more like a data sink, like just a data store where you put computed feature data that can then make it available in the online context. You see other solutions that provide different amounts of capability for actually defining feature views or defining features using transformations on raw data, and then varying levels of sophistication in terms of the kinds of features that can be defined, whether you have support for defining dynamic features that apply over time windows before, up until the event that you're making a prediction about. Support for features of features, or defining features as that are computed as a function of values of other features. There's various kinds of capabilities there. There's there is Yeah, so to kind of like maybe summarize that, there are some very simple solutions, and then there's some more complex solutions that are maybe tied to specific technologies and provide certain capabilities. Our approach is that we kind of think that there should be like a Swiss Army knife, as it were, about like making it easy for a machine learning engineer to define features based on data assets that already exist in their organization. So that means an expression language that lets you define features, like that help you with a good amount of the last mile of data munging in order to actually prepare a feature into something that would be, close enough to like a tensor form that you can be easily just injected into like a context for running a model or training a model. So that's Swiss Army knife and the kinds of things that are supported in the expression language and in the APIs. We have a set of those things based on what we found to be useful for LinkedIn use cases and that we think are generally useful. And what we want to, what we're building towards is to have that Swiss Army knife be, cover 80% or more of what people need to do, and where there's UDF support for the remaining 20%, and where you have really good management capability around those things, and where you have really good real-time support for those things, where you're able to properly simulate, backfill, and compute the values of real-time time variant features that are made with the Swiss Army knife APIs and expression languages, to be able to do that really well, and then to be able to deploy those and use those things in production. Those are aspects that we're pushing on and building for with Feathr. And some of the solutions, if you look at like the long list of things that are out there, are much more like the storage element. And that aren't covering, the Swiss Army knife of transformations and feature engineering kind of capabilities. So in a way, it's more than a store. Like there's actually the name feature store, and for some of these solutions, it does include more than storage. It includes things like feature engineering toolkits and things like that. It's a little more than the store, right? It also includes those kinds of capabilities that we see as kind of an important part of solution to the problem.
I muted myself so I didn't interrupt your your answer. Yeah, so definitely concur with we're still figuring things out. There's obviously a lot of like when somebody says feature store, there's some ambiguity about what that means. And personally, I've often felt frustrated at some feature stores that people are like, why don't you use this feature store? And when I look at it, it's a glorified database. It just gives me somewhere to like store the data. It's like, well, I don't know how much value add that's having. And so it's cool to see that there's like such a wide variety of different feature stores. But as somebody who's been in the trenches for a long time, I would love to just get a sense of, where do you think this is going? Where do you think feature stores are evolving towards? What's next for feature stores, or maybe more generally MLOps?
Yeah. I think that what is next for the things that I pay attention to, there are there's almost like a hierarchy of needs. We started out with having named features as entities people can reason about and can register and know what types they have and count on them to mean one thing, across contexts, training and inference and so on. Then we added a bunch of, Swiss Army knife kind of capabilities to define certain common features based on raw data sets. But there's like a expanding set of hierarchy of needs, kinds of additional things that you want to have to support an ecosystem around that. In terms of really easy visualization of the trends, of the data trends behind the features, or anomaly detection for making, making it easy for humans to understand the features that are defined and make sure that that they're looking the same way over time. Like there's things of that nature. Like how can I understand my current installation better and better? Can we continually polish and improve that? That's one direction where things are going to improve. The timeliness, the ability to have time, to have highly dynamic features that are based on some window of time that is in a rolling window, and to make sure the support for that is really, really, really solid, is another really huge area where, in my opinion, there's sort of an underuse in the industry of real-time signals because of the relative difficulty of actually dealing with um, the like stream processing machinery, which has come a long way, but is still not quite at the point, in my point of view, where, from what I've seen, where machine learning engineers are ready to pick that stuff up and apply it, unless they really know that they really need to do it for a specific problem. It's not yet at the point where like it's in the Swiss Army knife, where you can like try it quickly and validate the idea that some real-time signal is going to add a lot of value, so you can just like add it and deploy it. We're not at that level yet, but getting there, and Feathr's making a big play in that direction. It's going to be like really big in terms of helping a lot of applications in the industry move towards using real-time signals more, making better use of you know dynamic real-time compute and things like that.
Wait, is this
Farther
if
up, go ahead.
if I understand this correctly, you're seeing that because it's so hard to do real time and because there aren't the proper tools around it, people are just like, I'm not going to try for that because it seems or it is too complex.
Absolutely. So um, it's yes, I think that people, from what I've seen, people are ready to try things that they know that they can try in a reasonable window of time and get an answer about, like that they can try reliably, that they know how to use it, they can build something,
Mm.
see what the effect is going to be within a time window that is within their planning cycle, and where, because like the longer that takes, the more risky it is to actually try out something. I almost think about like, I mean, digging for oil or digging for gold or something like that. The easier it is to kind of know where to look and to be able to try, get in, get out quickly, and then it has a really big effect in terms of the productivity of that exploration. If you have a tool that lets you survey the field and really quickly versus if it's going to take you a year to survey the field, that's going to matter a lot. So definitely, I think that real-time signals are one example of something that, there's been a huge amount of interest in this generally over the past many years, since you have open source solutions, you have startups and other companies that are building support for just real-time data processing and stream processing. That's just like a thing by itself. But really, the application of that stuff for use in machine learning, in my opinion. Once we have better tools, like we're building feature stores that make it easy to do that stuff, we'll have a big spike, I think, in the interest of actually applying that stuff for machine learning problems, in my opinion. At least that's how I see it. I'm kind of curious to know what Skylar thinks about that and if he agrees.
Yeah, first time question's been flipped on me, but so uh, a lot of this reminds me of I don't know if you saw some time ago, Chip had a post that got a lot of notoriety. Machine learning is going real time. You're not ready. And I think I agree with a lot of things in that post. One thing that this is a bias based on the problems that I tend to work on now. uh, I look at a lot of problems, and there are a lot of problems where actually getting more real-time signals is not super helpful. There are definitely, like, I think in most problems, there are probably at least some collection of signals that, like, yeah, it's really useful to get it real time. So as an example, I work mostly in the space of mental health. And so if somebody indicates they're suicidal, yeah, I want to know that ASAP, and I want my models to understand that ASAP. But like somebody's like mental health doesn't like change instantly. Like if I got more data up to date right now, probably I'm going to make a prediction that's like pretty close to what it was like an hour ago. And so I think like it really depends on the type of problem you're working on. And I think that the reality is a lot of where the money has been in machine learning and as far as applications go, those are places where yes, having more real-time stuff matters. Like think advertising, like most of the state-of-the-art advertising systems now are like doing like nearline training even because like there's so much more to be gained there. Um, so I definitely agree. I think it's going to go there, but I almost think it's like an artifact of like the types of problems where money comes from, rather than being like representative of all machine learning problems and like being representative of like what everybody needs, so to speak. But I definitely concur
Yeah,
with the view that it's great to make this stuff easier because like the alternative is like probably like in most problems there's at least some collection of signals that'd be useful to get real time. And I think the reality is like even in places where there are those signals, people just aren't using them because there's such a big gap to like actually implementing it.
yeah, it totally
which
makes sense.
was
But yeah. Sorry, go ahead, Demetrius.
well, I was kind of going to follow that up with a question to you, David, around what some of the use cases you feel would be strong for this real time that aren't necessarily being leveraged right now, right? Like, and is it just more of what Skylar was talking about, like that stuff, that big money making stuff, or are there places that you feel like we could leverage real time, we're just not because it's so difficult?
Um, I guess I would say that we do have a like at LinkedIn, we do have a lot of use cases actually that are doing real time processing. We have a lot of support for this, and we have even like I think there's some other blog posts and things like that that we've released recently about real time computation, real time feature preparation or model training, things like this. So it is definitely used for some use cases where it is known and proven to be important. And we do get a lot of value out of doing that at LinkedIn. I think that just to clarify what I was saying before, I'm just in terms of personally as a focusing on like MLOps infrastructure. I really like to look for what I think are problems where if the infrastructure was a little better, it would actually unlock capabilities and investments in valuable investments for users because they're going to be like, okay, now that I can quickly try something, I'm going to try that thing more and then find out like, gosh, this is really useful. Like being able to do that, providing tools that let people try and find good solutions that would have been prohibitively complicated to try before, or at least more complicated than they were willing to spend, if that makes sense. Finding that kind of that edge and trying to move the kind of critical point of investment into something and move it to make it easier because the tooling is better, so it's easier to try. Is the thing that I'm particularly interested in. I agree that there are definitely use cases where uh, real-time signals, for example, matter much more, or where they matter less. When you're predicting things that are more stable, you obviously it's not gonna do that much to add real-time capability. But there are like certainly for personalization, where you're responding to real-time user behavior, you're trying to understand like how to help a user by putting the right search results in front of them based on something that they just indicated recently, things like that. I do think that there are a lot of places where we would get a increasing use with slicker and tools around that thing. Hopefully that makes sense.
Yeah, definitely. Yeah. That's definitely a future I'm excited for. Seeing how many people struggle with doing anything real time. I recall there were several times at LinkedIn where it was like, hey, we know that this would be a great real time signal to have. And, I think a lot of the real time features that we ended up having, it was a journey to get there, and so I'm very, very excited for that future for sure. Um, you're about to say something, Demetrius? All right. So one of the things I was thinking about, again, long time to get to this point of like having an open source release, and I'm just curious if there's anything about like through the process, and maybe not even just Feathr, but maybe your work more generally or more broadly. Is there anything that stands out as something that you're particularly proud of in that work?
Um, well, I'm very proud of the work that the team has done in terms of being able to actually do the heavy lift of getting a project that has been in existence for a long time and turning it into an open source solution that can be used outside of the context in which it was incubated and originally built. That's definitely not easy to do. So there was a lot of it was, like I said, a heavy lift. There are folks on the team who worked very hard to make that happen. We had help from our partners at Azure that I mentioned previously, who have done a lot of work to make this thing useful in the outside of LinkedIn context. Even though we had built it for years within LinkedIn, anyone who's built a big software project at a medium-sized to big company over the course of many years knows that over time you do get like a lot of you get layers of dependencies and relationships with other internal tech, and the ability to actually rationalize those things and lift and make a release that works outside the context is obviously a lot of work. So I'm just super proud that we delivered that, and that we are that this solution is out there right now, producing value for other teams and companies outside LinkedIn. I just think it's really, really cool to see that at this point in the life cycle of this project that I've been working on for a long time. So that's the thing that I'm most proud of, I guess. If that answers what you're
Yeah.
what
So
you're asking
modest.
there.
Yeah, I love it. So if you were to get to go back in time and do one thing differently when you were open sourcing Feathr, what would you do differently? Because I'm sure there was a lot that you learned along that journey of open sourcing it.
Yeah, this is interesting. I think there's a lot of reasons why we do and don't do things that are based on the focus and the priorities of teams and the needs of internal users, and various factors right over time that are kind of hard to fully characterize. So it's not like I could go back and change it. It's not like I would go back and take a different turn, because I think we respond. We went on the timing and the roadmap we did for those various kinds of reasons. But I would say open sourcing sooner would have been nice. It would have been easier to do earlier on, and there would have been fewer uh, bumps in the road. But then again, there are reasons why we didn't do that. We were very focused on supporting LinkedIn internal users and building what we thought was a good solution, and supporting different kinds of migrations. Doing these kinds of obvious things. So we didn't get to it sooner. But if I could change anything about the timeline with regards to open sourcing, or I would have done it. I would have done it earlier. I think that it's cool that we've been in domain for a while, and that would have been one thing. Other than that, yeah, I'll probably leave that one at that.
Oh, that's a perfect answer, and that's a perfect one to end on. I really appreciate you taking the time. I learned so much, man. You're such a deep thinker, and you obviously like choose your words very carefully. I love how much thought you put into each sentence, as opposed to me. I just kind of like verbally vomit all over the place and ramble on. But man, there's so many great takeaways on this, and Skylar and I are gonna talk about them right now. I can't thank you enough for coming on here, David. And we will hopefully be seeing more of you when it comes to Feathr. I think the last question is, and we can leave this at the very, very end, so in case we need to bleep it out, we can. When are you going to spin out Feathr into its own company and do that playbook?
Well, yeah, there's no plan to do that. I think that one of the things that I tell people, and that is, this is really the truth, is that LinkedIn is actually a great place to incubate a technology like Feathr, because we have a huge variety of just businesses and teams that are doing machine learning, large scale, small scale, different kinds of problem domains. Like there's and the company is big, but it's not like too big. You can still meet people and bump into them in the cafeteria if you're in the actual office and learn from users about what matters to them. Kind of like how I know Skylar, because he was really on one of the user teams, the internal users within LinkedIn, that was making use of the Feathr frame, and the other machine learning platform tools that we've been working on and trying to build and improve over the years. So being able to have close relationships with a large variety of applied ML users is like a great place to build a really good solution. Just in terms of like your question, Demetrius, I had a friend who have a friend who asked me like years ago, like when like 5 or 6 years ago, when I was thinking of this new project. I had a question from a friend like, "Oh, you're building like a new project around this interesting thing. Like, why are you doing this at LinkedIn? Like, why wouldn't you just go like try to talk to someone, get funding?" And I was like, well, I actually think that it's like I can do a better job of building a better thing in the context at LinkedIn, because I have, I know all these users, I know these problems, I can talk with them, I can see their code, we can sit together, we can build something there. So that's kind of the answer to your question. I would turn around and say that like LinkedIn's actually a great place to do this stuff. There's no plan to make it another company. If folks want to actually come and help build really great MLOps tools for LinkedIn, I mean, like for the industry, you can come do that at LinkedIn, and I'd be happy to talk to anyone who wants to do that.
There we go. You hiring?
Yes, we are hiring.
There we
so,
go.
You can ping me if you're interested.
Awesome. Dude, well, sweet. We'll end on that. Thank you, David.
Thank you very much. It's my pleasure, and hopefully we'll talk again.